So this is going to be your instructional video for lesson 9, which is about the factoring method for solving quadratics. I'm going to try this whiteboard, see if it works for these, okay? Quick review, from what we were solving prior to today, like this was last week's method. If we were going to solve this, we would be isolating the variable because there's only one, right? Because we didn't have a b value in here, or b was actually 0, we can just use this isolate the variable trick, right? Solve for x by doing inverse operations. Now, what this means, remember, if we get a positive and a negative, is that we have two x-intercepts, right? So x-intercepts are when y is 0, so we also call them the zeros. Okay, so these are also called the roots. Okay, so just a little bit of review before we jump into this new strategy here. Excuse me. Okay, so let's do some pre-thinking here. You'd probably do these in science, this if and then statements. So if 4 times a equals 0, then you think about that for a minute. What has to be true if 4 times a equals 0? A has to equal 0, right? Let's make it a little, I think I'm going to write a little fatter here, more general. What do you think? Oh, we've got some choices. A equals 0, or b equals 0. But there's another. Can you think of it? Both could equal 0. Okay, and this right here, right, all of this is called, let me get this a little darker, zero product property. And you'll see this abbreviated ZPB. I like to do a French accent for some reason when I say that. I'll tell you why, or I'll try to find a little video clip so you know why I like to do that. ZPB. So the zero product property is just that if we have one factor is 0, our product's going to be 0, right? So if our product is 0, then one of the factors is going to be 0. And in our case, both of them, right? So you can see why this whole 0 idea would be helpful to us, because when we're solving for quadratics, we are setting that to equal 0 when y equals 0, right? So if we're asked to solve x squared plus 5x plus 6 equals y, okay? Well, first thing, remember, is we're going to take that y off and put instead 0, right? Okay, let's try to, can't isolate, right? Because this is not 0 because we have two variables. I can't isolate. I can't use that square root property. So if you were paying attention to the name of this lesson, it's to factor. And our strategy when we factor is to say, well, what is A times C? B, numbers that multiply to B, 6, but add to B, 5. So easy enough, right? So when I factor this, because I don't have an A value, just plop these right into my binomials, right? X plus 2, x plus 3, and it equals 0. Well, A times b equals 0. Right? I'm going to move this up, hopefully. So either x plus 2 equals 0. Sorry. Oops. Or x plus 3 equals 0. And, you know, in our case, we know it's probably going to be both, right? Because this parallel is probably crossing the x-axis twice, right? Here, we're going to subtract 3 from both sides. Okay. Right. We're going to get x equals -2. Here, we're going to get x equals -3. And so as solution sets go, I'll put -3, then -2. Those are the zeros, the roots, the x-intercepts, right? If I wrote them as ordered pairs. Now I have a question for you on this. Is this in the form right here, right, of x minus root 1 and x minus root 2? Well, we knew if this had been simplified to an addition sign instead of a subtraction, it must be because we were subtracting a negative. Here, if it was simplified to addition, it must be because we were subtracting a negative. So we knew before how to find the roots without this method. So why do we go through all the trouble for this method? I'm going to show you that in the next set of examples, okay?